this presentation. Good morning.
Good morning. Can you hear me?
Yeah.
Okay, good. So I'll have a look or a short talk about like the critical assessment of technology that eShip will look into and try to integrate. And the problem from which we have to start basically is that there is a lot of technology available in the market that is not yet proven yet. It is not ripe for prime time, and it also is overhyped. So that means that we put a lot of potential into a technology, but this potential is never materialized. Gartner, a famous consulting term, has created something that they call the hype cycle. And in their critical assessment of the hype cycle, right, they figured out that most of the technology that they believed 20 years ago to be commonplace today has not achieved the technology maturity to be usable today, or just in a way fizzled away. It never reached the market in any place. One of those technologies that we put a lot of hope in today is the blockchain as kind of this is how they promise it, right? A system that allows us to share data among different parties in a secure and reliable way. The problem that I see with blockchain is that what we want blockchain to do for us, we could do already before blockchain was invented. And the things that blockchain adds to the story actually turns out to be a big problem. So why do I say this, right? What is the story behind blockchain? Blockchain, the name was invented by Satoshi Nakamoto, a pseudonym for the inventor of Bitcoin. What he did is that he took a couple of existing components and created a distributed payment system / cryptocurrency. And the main ingredients of Bitcoin or the Bitcoin blockchain is a peer-to-peer payment network built around a distributed ledger. That you can see basically as a database that records all the payments in real time. Each individual payment is authorized using a so-called hashed message authentication code. So in a way, that is a mathematical mechanism that takes any form of message and allows me to attach a signature to that message and also a mathematical digest, a so-called hash, to prove that after I have signed the message, it is not going to be changed, or it has not been changed. This building block is crucial to one of the key technologies that we want to support in digitizing any shipment technology. It is a crucial component to sign contracts electronically. And we do this today without even using a blockchain to support this. Right? So the people behind Bitcoin identified this technology as a good part of a payment system, and I agree with this. The second part that they are using, and this is where the name blockchain comes into the mix, is a timestamp server. This is a mathematical mechanism, an algorithm that certifies that a message, a transaction, or a block of transactions in the case of Bitcoin has been created and not been altered before a sequence of other blocks. The best way to understand a timestamp server is that it basically performs the task of a notary, right? It is also the task of a notary to certify that a document has been submitted and agreed upon at a certain time. And this is also a technology that we want to support in eShip to digitize our contracts and to basically make sure that we have a recorded timeline of all the negotiation steps and the signature of those contracts. The third mechanism in Bitcoin and in the blockchain is a so-called agreement procedure. So basically the problem of Bitcoin is that it is completely decentralized, right? Everybody can basically propose a new block of transactions to be appended to the system, right? And we, in order to avoid that money is spent twice, we need to have a mechanism that ascertains that we all agree on what payments have been processed by this network. Bitcoin's solution to this is called proof of work. And this is sadly the downside to this technology. You see, proof of work basically takes a complicated mathematical problem that takes a lot of time and energy to compute a solution to, but that is very easy to check, right? So once you know a solution, it takes almost no effort to see that this is a solution to the problem. As of today, right, the blockchain or the proof of work mechanism that is also called mining consumes more electricity than the nation states like Argentina. And a recent report also claims that a coal mine fire in China basically disabled more than half of the computational power of the Bitcoin network. So if this report is correct, right, we can also see that blockchain, or this mechanism inside of blockchain, contributes a substantial part, or substantially, so better to say, to greenhouse gas emissions. And this is, in a way, something that we want to avoid, that we claim to provide you with a green technology, and at the same time, we create a lot of greenhouse emissions, right? So what do we want, right? I told you that we want to have hash message authentication codes and cryptographic signatures to sign our contracts. We want to have a timestamp server to notarize our contracts. We also want to have something that we call smart contracts, which is a mechanism to automate the steps of contract execution. But what we do not need is the agreement mechanism. And one of the crucial reasons why we don't need it is, as speakers before me said, the parties involved in shipping trust each other. And this is a solution for a problem where we do not trust each other and where we are many parties. So just to show some examples that support my point, the German government asked for the development of a digital vaccination certificate, right, to allow people to prove that they have been vaccinated against COVID. And the proposed solution not only stored the vaccination certificates they claim on one blockchain, no, they stored it on 5 blockchains. privacy advocates then quickly identified that actually the blockchain they use doesn't store any data. It's actually completely useless to prove that you have been vaccinated. And today the same system basically operates without any blockchain. A second example is a similar project in, I think, the state of New York, where they decided to put the certificate itself on a blockchain. Now, the distributed and shared nature of the blockchain without security precaution would allow you to basically find out who has been vaccinated and who has not been vaccinated, right? So you have a privacy leak that potentially could lead to a partitioning of a society in groups of vaccinated and unvaccinated people. So now let's talk a little bit about smart contracts. Smart contracts basically puts little programs into a shared data structure to execute the steps of contract execution, right? So you would basically have little programs that would say, if goods have been delivered, we will issue a payment. How does now this computer program know that something has happened in the real world? That is something that we refer to as the Oracle problem. Typically, right, we have the fear that somebody could trick the smart contract in issuing a payment without having received the goods that we wanted to deliver. Again, this is a matter of trust. And here we can establish trust using the Internet of Things. The Internet of Things started out as a set of technologies for machine-to-machine communication. So we have physical entities, so-called things, that can either actuate in the real world, say stepper motors, or that can measure things happening in the real world, for instance, cameras. These produce a wealth of data that we can use for many steps of our system. So if we can trust this part of the Internet of Things, we can basically use it to issue the performance or to proceed with the performance of our smart contracts. Now, there is a very important point about the name of smart contract, because the focus here is on smart. It is not on contract. So the programs in itself are not the legal document that shippers or charterers and ship owners and brokers will agree on. It is a technology that automates the execution of such contracts. The data that the Internet of Things provides will also enable us to create or to make shipping much greener, right? Because if we are able to basically record and analyze greenhouse gas emissions, fuel consumptions, progress of ships, and so on, our system will possibly be able to recommend changes in routes and speed of the ships to reduce greenhouse gas emissions by a large margin without actually increasing the time of voyage by a large amount. Typically, I mean, this is basic physics, right? Increasing the reducing greenhouse gas emissions means to burn less fuel, and that would make ships, of course, travel slower. There's always a price to pay for these kind of things, but if we put value into reduced greenhouse gas emissions, we can basically justify such delays. We already see examples of this happening today. For instance, if you own a Tesla car, right? Tesla, the car will gather a lot of data about your driving behavior in order to improve the estimate of the remaining range and to optimize the battery performance. This kind of data gathering also comes with its own set of problems about data sovereignty and who has access to the data. And a very prominent case in Iceland, the same data that Tesla gathers about your car was used to convict a car owner of speeding. But still, with all those risks, right? We do not want to discard the data or put inappropriate barriers in the use of this data. So another problem that we are looking into is the use of historical data. The starting point that we have today is that a lot of data exists, and the data is in all kinds of different formats. They are used by the respective ship owners, by the charterers, by the brokers for their own internal processes. And history shows that it is unlikely that these data sets will be converted into some uniform data format. It often even does not exist in a structured way. Here we see the potential of, for instance, using artificial intelligence and natural language processing to extract the relevant data from all pre-existing contracts and what else has been gathered. This method, right, artificial intelligence, however, also comes at a cost. In order to build the system that is able to extract this data, we need annotated data in the beginning, right? So we have to teach the system to understand the data. And that means that we need to have a teacher that knows how to interpret this data. Once the system has been trained on a sufficiently big set of such data, it will be able to automatically understand new contracts and give us the data that we are interested in. Since we expect a lot of language barriers here, I think that we need to have a lot of work in improving processing of the data. So that, in a way, gets me to a conclusion, because if you look at potential solutions to this, again, I see certain risks, right? And let me start with a now rhetorical question. Do you remember any person that has become a millionaire from digging for gold in California? I don't. Right? There are probably only one or two persons that became millionaires from digging for gold. But there are many people that have become millionaires from selling shovels and pans. So that is to tell you that a lot of value is actually made from the infrastructure to mine this data. Consider, for instance, Amazon. Amazon does not earn its money from selling books or from its Amazon store. That, more often than not, is actually losing money. Most of the money in Amazon is made in Amazon Web Services and its marketplace, right? So Amazon sells you the infrastructure to do your business. Sadly, and that is a risk, Amazon is currently investigated for allegations that Amazon uses the data of its customers to compete against its customers. Especially there is a suspicion on the marketplace that people that bring innovative products to the market will face copycat products made by Amazon as that competes against you at a lower price. The same may happen also in the shipping market. So I'm not alleging that Amazon will be doing this, right? But that is a risk that we have to face, so that everything that happens in the cloud can be exploited by competitors. So if Amazon is in the shipping business and Amazon is starting to sell you a shipping service like we intend to do, what assurance will Amazon give us that it will not compete against other providers on their service? Still, I mean, Amazon has a bad reputation, but Amazon has, at least it looks like it, appears to provide valuable service like all its other competitors like Oracle and Microsoft. So having what we envisage, or what I envisage, what a good solution to today's problem actually is to provide a conduit between all kinds of technologies and services that allows people, our customers, to unlock the value that is inside of their existing data, right? And that we can build a relation of trust between our customers and us, that they can trust us with their data, that we will help them to obtain the data that is useful to them, right? And that we can build a system to recommend parties for specific problems. I think that in providing this kind of infrastructure to the parties, instead of replacing the parties, we'll have a much better place in the existing market. Thank you.
Okay.